Hello everyone and welcome back to MathZone. In this video, we are going to solve some past papers about circular measures. So let's look at the first question. Here we have a sector OAB with center O and radius R. And then we have angle AOB, which is theta radian. And then we know that the length of the arc AB is 9.6 centimeter. And the area of a sector OAB is 76.8. Now, the question is find the area of the shaded region. Now, let's start from what we know. We have length of the arc AB is 9.6 centimeter. So we can write the formula of the length of the arc AB. The length of the arc, the formula is radians times radius. So theta times r. Because we know that the length of the arc is 9.6, so 9.6 equals to theta r. By using the second formula of the area of a sector, because we know the area of the sector is 76.8, we know that the formula is the area of sector OAB. This is the formula of the sector, half theta r squared. Because we know that it equals to 76.8 equals to half theta r squared. Now, we do have two equations. We just need to solve it. As you can see here, you can find theta equals to 9.6 over r, or you can do r equals to 9.6 over theta, and then you substitute this or this to the second equation. Or I have simpler way, because we know that this is r squared, we can break it down into theta r times r. And we know that theta r is 9.6, so we can substitute theta r here, becomes 9.6. So 76.8 equals to half times 9.6. We substitute the theta r, multiply by r. Now from here, we can get 76.8 equals to half times 9.6 is 4.8 r. So r equals to 76.8 divided by 4.8. And then you can use calculator to solve for r, which is equals to 16. Now, after we get r, we can find theta. Because we know that 9.6 equals to theta r, so theta equals to 9.6 divided by r. So we substitute r, which is 16. So 9.6 divided by 16 equals to 0.6. Now, we have the value of r and the value of theta that we need to know, because the question is find the area of the shaded region, which is this area. To find this area, we need to subtract the area of the sector minus the area of the triangle. So the area of shaded region, let me write down here, area of shaded region. So the area of a shaded region equals to the area of sector OAB minus the area of a triangle OAB. So area of the shaded region equals to area of sector OAB minus the area of the triangle OAB. Now, because we know that the area of a sector is 76.8, we don't need to calculate that using the formula again, minus the area of a triangle. How do we find the area of a triangle? Keep in mind, we can use the sine rule for the sine formula for the triangle area. This is the side, this is the side that we know, and then we have the angle in between. So we can use the sine formula for area of a triangle, which is half times the first side times the second side times sine of the angle between two sides. So we can write down 76.8 minus half r squared sine theta. So we just substitute the r and the theta that we know. So 16 squared minus sine 0.6. And then you take your calculator, and keep in mind that you have to use radian mode in your calculator because 0.6 is in radian. So always use radian when you want to solve circular measure problems. And then when you use calculator, you will get 4.53. So this is the area of the shaded region. Now, how do we find the perimeter of the shaded region? If you see the shaded region, the perimeter, you just need to add the arc length, which we already know, 9.6, plus the straight line, AB. So if you want to find the perimeter of the shaded region, you just need to add the arc length of AB plus the straight line of AB. Let me write down like this. So, because we know that the arc length equals to 9.6, now you just need to find the length of AB, the straight line, AB. How do we find that? If you look at the triangle here, we can divide our triangle into two, like this. And then this will give you right angle triangle. We already know that the theta is 0.6 because we divide by 2, we will get this angle is 0.3 because this whole thing is 0.6. We divide by 2. So we want to find this length first. Okay, so how to find this length? Let's call it x. We use SOHCAHTOA. We know the opposite. We know the r. Yeah, we need the x. We know the r. So we use opposite over hypotenuse, which is sine. So by using sine equals to x over r. So sine 0.3 equals to x over r. So x equals to r sine 0.3. And we know that r is 16. So 16 times sine 0.3. Use your calculator to get approximately 4.728. Now this is the x value, but we need the length of AB, which is twice the x value. So you need to multiply by 2. So from here we get the length of AB, the line AB, will be 2 times 4.728. And then you will get 9.45, 4.728 times 2, 9.456. And then we can round off later. We just write down here first, 9.456. And then you add, you will get 19.056. And then you have to round off to 3 significant figure. You will get 19.1. Let's move on to the second question. Here we have a sector OAB with a circle with center O over here. Angle AOB is theta radians, and OP equals to AP, which is equals to x. Show that the arc length AB is 2x theta cos theta. Now, because we want to find the arc length, we know that the formula of the arc length is AB, the arc length of AB equals to radians times radius. Because we know that the radian is just theta, so we need to find the radius from O, which is the center of the circle, to A. This is our radius, or we can also use this. By multiplying radians with radius, you will get the arc length. But the problem here is we don't know the radius. So how do we find the radius? Now, let's focus on our triangle here first, OAP. As you can see, OAP is the isosceles triangle. Because as you can see, you have two sides equal in length. That means if this is isosceles, we can divide this triangle into two and you will get right angle triangle. So when you divide by 2 like this, when you have isosceles and you divide by 2, you will get 2 equal right angle triangle. So here we have the right angle triangle over here. So we can find the value of half the r first. So let's find the value of half r because we divide by 2. And then we can find OA just multiplying it by 2 later. So half A, we can use the SOHCAHTOA because we get right angle triangle after we divide our triangle here. So this is our angle. And then we know the adjacent and we have the hypotenuse. So that means we can use the cosine. So cosine theta equals to adjacent is half r over the hypotenuse is x. Yeah, you can rotate the triangle. Maybe it looks like this. The x is here, and then this is the theta radian, this is the half r. As you can see, this is the adjacent over hypotenuse. So you will get x cos theta equals to half r. Because you want to find r, which is OA, the radius that we want to find, so you just multiply by 2 both sides, you will get r equals to 2x cos theta. So we substitute to find the arc length, which is theta. R is 2x cos theta. So you will get 2x theta cos theta, which is same as the equation given. The second one, we want to find the area of the shaded region APB in terms of x and theta. Now, let's look at the picture once again. Here we have the area of the shaded region APB. Now, how to find the shaded area APB? You just need to subtract the area of a sector OAB minus the area of this triangle. So let's find the area of this sector first. Area of sector OAB equals to, the formula of area of a sector is half theta r square. We substitute, we know the theta, the r we get it from the previous one, which is 2x cos theta, so substitute 2x cos theta square. So you will get 2 square, and then you multiply by half, you will get 2 theta x square. Maybe I write down x first. 2x square theta cos square theta. Now, this is the area of the full sector. Now, let's find the area of this triangle. Now, because we know that this is isosceles triangle, and when you divide by 2, you will get the area, you will get the right angle triangle. Let's just use base times height over 2. Because this is the easiest way to find the area of the right angle triangle. So let's see here. Sorry. Okay. Let's find the area of the half triangle first. Okay. This is the base. 1 over 2r. We need the height. Right? Now, what is the height over here? Let's call it h. We can use the tangent, or you can use cosine to find the h. The easiest one, use the x. So x and h, because x is given in the equation. We know the x, but we don't know the h. So we can use the opposite over hypotenuse, which is using sine. So sine theta equals to h over x. So h equals to x sine theta. So the area of the half triangle will be okay, let's write down here. The area of the half triangle will be base times height over 2. So base times height over 2. So half r times x sine theta, and then divided by 2, like this. So you will get 1 over 4 rx sine theta. This is the area of the half triangle. So that means if you want to find the area of the full triangle here, OAP, you just need to multiply by 2. So you will get area of full triangle, OAP, will be equals to 2 times the area of the half triangle. So from here you will get half r x sine theta, but we know r, right? And the question just allow us to use x and theta, so substitute r. So half r is 2x cos theta, x sine theta. So you will get this cancel, you will get x squared sine theta cos theta. So we just subtract to find the area of the shaded region, which is APB. You subtract the area of the sector, which is 2x squared theta cos square theta minus x squared sine theta cos theta. If you want to make it simpler, you can take out the x squared and the cosine theta. You will get x squared cosine theta. And then we have 2 theta cos theta because it's cos square minus sine theta. So this is the final answer. Okay guys, let's move on to the third question. Here we have ABC is a semicircle with diameter AC, center O, and radius 6 cm. The length of the arc AB is 15 cm. Point X lies on AC and BX is perpendicular to AX. Find the perimeter of the shaded region BXC. So, if you want to find the perimeter of the shaded region BXC, you need to know BC, and then you need to know XC, and then you need to know BX. After you get all of this, you just need to add them all to get the perimeter of the shaded BXC. So, how to get BC? Let's start from the easiest one, BC. Because we know that ABC is the semicircle, yeah. So, when we take the circumference of the semicircle, we know that the perimeter formula of the one circle, perimeter of one full circle, is 2 pi radian. So that means the perimeter of the half circle, which is the semicircle that we have now, it's just pi r. So by knowing this, we can calculate BC because we know that BC equals to the perimeter of the half circle, pi r, the whole thing, minus AB, the arc AB, which is 15 centimeter. And then we just use calculator. We substitute first. R is 6. So 6 pi minus 15. Let me calculate first. You will get 3.8496. That is BC. Now, after we find BC, how do we get BX? How do we get XC? Now, let's start from what we know. We know that arc length AB is 15 centimeter. So now let's focus on this sector. Yeah, because we know that the arc length is 15 and we know that the radius is 6, we can find the radians created by the 15 centimeter because we know that the arc length formula, which is 15 equals to radians times radius. So by substituting our r, so r is 6. So 6 theta, so theta is just 15 divided by 6. And then you will get 2.5. So this is 2.5. If this is 2.5, how big is this angle? Because this is a semicircle, this is 180 degree or pi radian. We use pi. So, for OBC, angle OBC, so we write down here angle BOC, angle BOC equals to, for the half circle is pi radian minus 2.5 radian. So you use calculator, pi minus 2.5, you will get 0.6416. So now we get this angle. Now it's easy to find the rest because we know OB. Even though it's not written there, we know that OB is another radius. So this is 6 centimeter. Now, to find BX, you can use SOHCAHTOA. So BX, this is the one that we want to find. This is the opposite, and we know the hypotenuse. Opposite, hypotenuse. So we can use sine. So sine, sine of 0.6416 equals to, the opposite is BX and the hypotenuse is 6. So BX equals to 6 times sine 0.6416. And then use calculator to find BX. 6 times sine 0.6416. And then you will get 3.591. Now, we already get BX, already get BC. How do we get XC? Well, you can use any method you want because we already know BX, right? We know BX, we know OB. You can use Pythagoras or you can use cosine. Let me use cosine. So, by using cosine, we can find the adjacent, which is OX. So, cos 0.6416 equals to the adjacent, OX, over hypotenuse, which is 6. So from here, you will get OX equals to 6 cos 0.6416. And then use your calculator. 0.6416. You will get 4.8068. That is OX, but we want to find XC. Well, XC is just OC minus OX. We know OC. This is just another radius. So XC equals to the radius 6 minus OX, 4.8068. And then you will get the answer equals to 1.193. Now, it's easy. The perimeter of the shaded region BXC, you just add them all. This is our BC over here. We have BX, which is 3.591, and XC is 1.193. So you add them all. So the perimeter of the shaded region will be 3.8496 plus 3.591 plus 1.193. When you do calculation, it's better to use 4 or 5 significant figure to make sure that your result is more accurate and similar to past paper mark scheme. And then you will get 6.8336. Make it 3 significant figure, you will get 8.63. So the answer is 8.63. Hello guys, let's continue to number 4. Here we have in the diagram the lengths of AB and AC, 15 centimeter. And then we have point P, which is the foot of the perpendicular from C to AB, so it's 90 degree. And then we have the length CP is 9 centimeter, and then we have an arc length here with center B. Now, the first question is we need to show that the angle ABC, which is this one, let's call it theta, equals to 1.25 radians, correct to 3 significant figures. Okay, so now let's look at our shape first. Now, because we know that ABC, AB and AC are equal in length, that means ABC are isosceles. So this theta will be equal to this theta because this is isosceles triangle. So now, because we know that these two are equal, we can find this angle by using APC triangle. Because in APC, we have 15 and 9. And this is right angle triangle. After you find this angle, you can use the total angle in triangle to find theta. So, how to find this angle? Yeah, this is a BAC angle. BAC. So how to find BAC angle? This focus on this triangle, right angle triangle APC. We have the opposite and we have the hypotenuse, so we can use sine. So sine of BAC equals to opposite divided by hypotenuse. So we can get BAC equals to sine inverse of 9/15. And you will get 0.6435. Now, because we already know the angle of BAC, how do we find the angle of ABC, which is theta? Because we know that the total angle in a triangle is 180 degree, or in radian, we use pi radian. So when we add BAC plus theta equals to pi. So this angle plus this angle plus this angle equals to 180 degree or pi radian. So here we have BAC plus 2 theta equals to pi. Let me substitute BAC 0.6435 plus 2 theta equals to pi. So 2 theta equals to pi minus 0.6435. So we can find theta pi minus 0.6435 over 2. When you substitute that to the calculator, you will get 1.249, or because you want to make it 3 significant figure, that will be equals to 1.25 radians. Proven. Now, let's look at the second question. Calculate the area of the shaded region which is bounded by the arc CQ and the lines CP and PQ. So we want to find the area of the shaded region because we know that QBC is the sector. So if you want to find this area, you need to subtract the area of the full. Let me erase the highlighter first. So we focus on this sector. Yeah, because we know the formula of the sector. QBC minus the area of this hollow triangle, you will get the area of the shaded region. So how do we find the area of the QBC, the sector QBC? Just remember the formula of the sector, QBC, is half theta r square. We know the theta, but we don't know the r, which is BC. So how to get BC? To get BC, you need to know PB. Because if you get PB, and you just use Pythagoras with the 9 here to get BC. And later on, you need PB as well to calculate the hollow triangle. So how to find PB? Well, PB is just AB minus AP. So we need to find AP first. Okay, how to find AP? Once again, focus on this triangle. This is 9, this is 15. So this creates right angle triangle. You can use Pythagoras to find AP. So let's find AP first. Let me do it here. So AP equals to square root of 15 square minus 9 square. We use the Pythagoras formula. And you will get 12. It's a good number, a good sign for us. So AP is 12 centimeter and AB is 15. So PB is 3 centimeter. Now, because we know PB is 3, how do we get BC? Let me change the setting first. Okay. Now, to get BC, once again, you apply the Pythagoras for this small triangle. So BC equals to square root of 9 square plus 3 square. And then you will get 3 square root of 10. Now, BC is our radius. So now we can find the area of the sector QBC. So let's write down here for part B, area of sector QBC equals to half theta r square. The theta is 1.25. R is 3 square root of 10, and you square it, and then use your calculator. 1.25 times 3 square root of 10 square, you will get 56.25. Now, after we get the area of the QBC, we can use the PB and the PC to find the area of the hollow triangle PBC. So area of the PBC will be equals to base 3 times height 9 divided by 2. So 3 times 9 divided by 2. Use your calculator. You will get 13.5. Now after you get 13.5, now you can just subtract. So the area of the shaded region will be equals to 56.25 minus 13.5. You'll get the answer 42.75. Round it off to 3 significant figure becomes 42.8. So this is our area. Move on to the next question. Here we have the diagram shows a metal plate ABC in which the sides are the straight line AB and the arcs AC and BC. The line AB has length 6 cm and the arc AC is part of a circle with center B. So if we draw the sector created by the arc AC, will give you like this. Now this is the sector AC, this is the arc length AC with center B. And radius 6. So this is also 6 because it's radius from the center. Here's the center. And also same for BC. It comes from the center A. So we can take a straight line here with the same radius, which is 6 cm. The first question is find the perimeter of the plate, giving your answer in terms of pi. So if you want to find the perimeter of this plate, you need to add the length AB with the arc length BC plus the arc length AC. Now, how to find the arc length BC first? Now, if you look at the shape here, let's focus on the sector here. Yeah. If you want to find the arc length, you need to multiply the radians times the radius. But how do we find the radian value here? Well, if you look at the triangle here, this is equilateral triangle because all sides are equal. So the angle inside equilateral triangle will be 60 degree or pi over 3 radian. So from here, we have AB is 6 plus BC. We use the formula radians times radius, so pi over 3 times 6. Plus, how about AC? The arc AC will be equals to arc BC because of symmetry, so we just add with another pi over 3 times 6. So the perimeter will be 6 plus 2 pi plus 2 pi. So the answer is 6 plus 4 pi. The second question, we are asked to find the area of the plate, giving your answer in terms of pi and square root of 3. Now, if you want to find the whole area of this plate, we can find, first thing first, the area of this sector. And then you add with the area of AC, this small part. So, let's find the area of sector ABC first. So area of a sector ABC will be equals to, the formula of the sector is half theta r square. We know our theta is pi over 3 equilateral triangle, and our radius is 6 square. So you just calculate pi over 6 times 36, which is equals to 6 pi. Now, let's find the area of AC. How to find the area of AC? Area of AC. Now, because of symmetry, area of AC will be equals to area of CB over here, right? So we can find area of BC instead. So area of AC equals to area of BC. And how to find the area of BC? If you want to find this area, you need to subtract our area of sector with area of a triangle. And we know area of our sector is 6 pi. So 6 pi minus area of triangle. And what is the area of a triangle? You can use base times height over 2, or I will use easier method, which is using sine formula. Because I know the side, and then another side, and then angle in between. So we can use sine formula, which is half times the first side is 6, the second side is another 6, and sine of the angle between them, pi over 3. So we calculate 6 pi minus 18, half times 6 times 6. Sine pi over 3 is half square root of 3. So your area of AC, which is equals to area of BC, will be 6 pi minus 9 square root of 3. Now we add them together to find the area of the plate. The total area will be 6 pi minus the second area, this one, plus 6 pi minus 9 square root of 3. So you will get 12 pi minus 9 square root of 3. This is the answer. Move on to the next question. Here we have the diagram shows two identical circles intersecting at point A and B with centers at P and Q. The radius of each circle is R and the distance PQ is 5 over 3R. Find the perimeter of the shaded region in terms of R. So we need to find the perimeter of this shaded region. So, first thing first, let's break down. First, we have PQ, 5 over 3R. Now, let's focus on finding one of this first. Yeah, we have 4 of this then. So, if you want to find this, if you can see, this is the sector, right? But we don't know the value of radians. If we know the value of radians, we can find the arc length here, because the formula of the arc length is just radius times radian. But how to find this? We can create a triangle from A and make it perpendicular here. Now, due to symmetry, this is half of PQ, right? Because of the symmetry. So that means PQ is 5 over 3R. Half of it will be 5 over 6R. So focus on this triangle. We can use SOHCAHTOA to find the angle here. So we know the adjacent and the hypotenuse, so we can use cosine. So let's call our angle here theta. So cos theta equals to adjacent 5 over 6R over hypotenuse, which is R. So our cosine theta will be 5 over 6. So theta, you just use R cos to find the value of theta in radian. Let me use calculator first. The answer will be 0.586, or maybe let me use for significant figure, 5857. Yeah. Now, keep in mind, guys, in A level, maybe when it is not the final answer, maybe you can use 4 or 5 significant figures so that your final answer will be similar to the mark scheme later. So give one extra significant figure. Now, if we already know the theta, it's easy to find this angle. So let's say it's the arc length. One arc length, yeah. One arc length. You just multiply the radius with the radian. The radian is 0.5857. Radius is r. Because we want to give our answer in terms of r. Because our perimeter is the 4 times our arc length. 1, 2, 3, and 4. So the perimeter will be 4 times arc length that we have. So that gives you 4 times 0.5857 r. Use your calculator, 0.5857 times 4. You will get 2.3428 r, and you can make it 3 sig fig, 2.34 r. So this is the perimeter. Simple. And that gives you 4 marks. Very huge. Now, the second question, find the area of the shaded region in terms of r. So, if you want to find the area of the shaded region, it's the same thing as the arc length. Maybe we can find this area first. Okay? And how to find this area? You just need to subtract the area of a sector minus the area of a triangle. So let's call this point R. Let me redraw it. So we have PAR. Let's call it S here. PARS. So let me draw it. Okay. Approximately like this. So this is P. This is our A. This is our R. This is our S. Now, we want to find this area. ARS. And then after you get ARS, you just need to multiply by 4 to get the whole area of the shaded region. What do we know here? R, 5 over 6R, the theta, we know the theta, which is 0.5857. So this is 0.5857. This is R. The PR, it's PR, yeah. PR is 5 over 6R. Now, let's find this area. So to find ARS area, you need to subtract the area of a sector minus the area of this right angle triangle. So let's calculate the area of a sector first. Area of a sector, PAS, use the formula half theta r square. Our theta is 0.5857 times r square. We want to give our answer in terms of r, so just leave r alone. So just multiply half times 0.5857. You will get 0.29285 r square. And then we need to find the area of this triangle. You can use Pythagoras to find AR and then use the base times height over 2, which is wasting your time because we can use the formula of the sine formula for the triangle, which is area of a triangle, PAR, equals to half times the first side is r, the second side is 5 over 6r, multiply by sine of the angle between two sides, 0.5857. So put half times 5 over 6 times sine 0.5857 into your calculator and leave the r alone to get the value, which is equals to 0.23203 r squared, because r times r. Now you can get the area of the small segment ARS. You subtract the area of a sector, 0.29285 r squared minus 0.232 0.03r square. You will get 0.29285 minus 0.2303, 0.06255 r square. To find the area of a shaded region, you just multiply by 4. So area of the total area is 4 times the area of our ARS. 4 times 0.06255 r square. And you will get 4 times 0.06255, 0.2502 r square. If you want to make it tricyclic, 0.250 r square. So this is our final answer. Let's move on to the next question. Here we have the diagram shows a circle with center O and radius r centimeter. The points A and B lie on the circle and angle AOB 2 pi radians. The tangents to the circle at A and B meet at T. So these lines are tangent line to the circle. Express the perimeter of a shared region in terms of r and theta. Now, to find the perimeter of this region, first thing first, we need to find the arc length of AB. And then you add with AT and PT. So, the perimeter will be AB, arc length of AB, plus AT plus BT. Now, to find the arc length of AB, you just need to multiply radians with radius. So, it gives you 2 theta r, 2 theta times r. And then, to find AT, this is tricky because you have to know that if AT is a tangent line, means that tangent line and radius always create 90 degree, which is perpendicular. And then you can divide this into 2. So this gives us theta because the whole thing is 2 theta and we divide by 2. And we can apply the SOHCAHTOA formula to find AT. So we have the adjacent and we want to find the opposite. So you need to use tangent. So tangent theta equals to AT over R. So AT equals to R tangent theta. So AT will be equals to R tangent theta. And due to its symmetry, BT will be equals to AT. So that also equals to R tangent theta. So the answer will be 2 theta R plus 2R tangent theta. Now, in the case where R equals to 5 and theta is 1.2, find the area of the shaded region. Okay, so now we need to find the area of this shaded region. To find the area of a shaded region, first thing first, maybe we can find half of it first. Maybe we can find this area first. Let's call it area 1 will be equals to area 2 later. And we just multiply by 2 to get the total area. Now, to find this area, you need to subtract the area of the triangle with the area of a sector. Now, let's find the area of a triangle. Because this is right angle triangle, you can rotate the triangle like this. This is R, this is AT, right? The AT is R tangent theta. This is a 90 degree. So this is the base, this is the height. So to find the area of OAT, you just need to use base times height over 2. So let's calculate the area of triangle. Triangle OAT. Base times height over 2. The base is R times R tangent theta over 2. That gives us R square tangent theta over 2. We are given the value of R and theta. So just substitute 5 square tangent 1.2 over 2. That gives us 25 times tangent 1.2 divided by 2. 32.15. Now, To find the area of the shaded region, area 1, you need to subtract area of the triangle that we have calculated before with the area of this sector, this part. So let's calculate the area of a sector. Because the theta is 1.2 and this is our r, we can use the formula of a sector. So area of a sector will be half theta r square. Our theta is 1.2, our radius is 5. So you will get 0.6 times 25, 15. So we can get the area 1, which is half of our total area, we call it area 1, will be subtract the triangle with the sector. 32.15 minus 15. You will get 17.15. So the total area will be 17.5 times 2, which is equals to 34.3. This is our final answer. Let's solve the last question for this video. The diagram shows a cross-section of 7 cylindrical pipes, each of radius 20 cm, held together by a thin rope which is wrapped tightly around the pipes. The center of the 6 outer pipes are A, B, C, D, E, F. Point P and Q are situated where straight sections of the rope meet the pipe with center A. So this is like the curved section of our rope. Show that the angle PAQ equals to 1 over 3 pi radian. This is a tricky question because you have to look closely to the picture that we have here. So if you see here, this is our PAQ. This is part of this circle. Now, let's collect all of the curved section that we have. We have 1, 2, 3, 4, 5, and 6. We have 6 curved section in total. So we can create the same pattern. Now, if we combine all of this, that will create a circle in the middle here, which is equals to other circle because all of them are identical. So this is, because we have 1, 2, 3, 4, 5, 6, so this is 1 over 6 of our circle. So the angle of PAQ is just 1 over 6 times the full circle, which is 2 pi. So that gives you 1 over 3 pi radians. So this is how we prove due to its symmetry by symmetry. Now, the second question, find the length of the rope. Now, this is not a tricky question. Let's look at our question here. The rope consists of 6 curved sections, and we have another part which is the straight section. We have 1, 2, 3, 4, 5, and 6. So the length of the rope will be equals to 6 times the curved section plus 6 times straight section, which you can see it from my picture here. The curved section, you have 6, the green one, and also the straight sections. Now, how to find the curved section? To find the curved section, this is just the arc length, right? With the center A, F, E, D, C, and B, all of them are identical. So we can just focus on this first. So we know that the angle is pi over 3, and we know the radius is 20. So this is pi over 3. The radius is 20. So to find the arc length, you just multiply radians with radius. So 6 times. The curved section is technically an arc length, so multiply radians with radius. How about the straight section? how long is our straight section. As you can see, this straight section starts from one center and ends at another center. We know that the radius is 20 and the radius of another circle also same 20, so the total is 40. So the length is 40, the length of our straight section. So one straight section is 40, so 6 times 40. And then we just calculate here, we have 40 pi plus 6 times 40, 240. So 240 plus 40 pi, and when you calculate that, gives us 365.66, or if you round off to 366, become 366. So the answer is 366 centimeter. Now, the next question is find the area of the hexagon ABCDEF. So let's draw our hexagon first. Let's connect our hexagon here. Okay, now how to find the area of our hexagon? Now, if you look at our hexagon, we can create 6 triangles. So if we take a center here, we can create triangle. Right? We have 6 triangles here. That means the angle also same, which is pi over 3. Because we divide our circle or hexagon into 6 sections. So the angle will be pi over 3. Now, how about the length? Because we know that the straight section is 40 from the previous calculation. So that means our AB here is 40 centimeter. So all of them will be 40. BC, DC, and so on. Now, because this is pi over 3, if we convert that into in degree, will gives us 60 degree. So pi over 3 is the same thing as 60 degree. And because this length are equal due to its symmetry, so we can say that the angle also pi over 3, right? So this is pi over 3, this is pi over 3. Because this is equal, and that creates isosceles, and this is 60 degree. So this will give us 60 degree and 60 degree as well. And because all of them are equal, we can say this is the equilateral triangle. So this gives us 40, and this gives us 40 as well. So all of them are 40. It turns out it's equilateral triangle. So to find the area of our hexagon, you just multiply our area of the equilateral with 6. So 6 times area, let's call it O here, AOB. So the formula of the area OB, you just use the sine formula. 1 over 2 times 40 times 40 times sine in between pi over 3. So let's use calculator here. We will get sine pi over 3. The answer is 4156.921. Or maybe I will just calculate the exact value. Oh, the answer must be in terms of square root of 3. So let me calculate manually. So 6 and 2 becomes 3 times 1600 times sine pi over 3 is 1 over 2 square root of 3. This with this gives us 800. So 800 times 3 is 2400 square root of 3. So the answer must be in exact because the question asks us to make it in terms of square root of 3. So this is our hexagon area. Now, the last question is find the area of the complete region enclosed by the rope. Now, to find the area of the complete region enclosed by the rope, first thing first, we already get the area of our hexagon. Now, the area of a hexagon, you just add it with the area of rectangle here. But how many rectangles do we have? We have, let's calculate it first. Now, approximately we have 2, 3, and then another 4 here. 4, we have 5, and 6. So we have 6 triangle. We already get the hexagon plus 6 times area of the rectangle plus area of this pizza, slice of pizza. They are 6. If you add them all, it will create one full circle. So all of this combined become one circle. So the area of the complete region will be area of hexagon plus 6 times area of rectangle plus 1 area of a circle, which is the green one. Area of one circle. So let's calculate. We already get the area of hexagon, which is 2400 square root of 3. And then we find the area of rectangle because we have the length is 40, the width is just one radius of this circle, which is 20. So 40 times 20, 6 times 40 times 20, plus area of one circle, because our radius is 20, so just pi r square, so pi times 20 square. So 2400 square root of 3 plus 40 times 20, 800 times 6, 4800 plus 400 pi. So let me plug it into my calculator to get the final answer. Equals to 10,213.6. Make it 3 sig fig become 10,200. So this is our final answer. Thank you for watching this video. I hope this can help you to solve past paper about circular measure. Thank you and see you in the next video. Bye bye.